A pleasant day, everyone. Welcome to the General Chemistry 2 class. This section is on chemical equilibrium. This lesson is about part 4, predicting the direction of reaction from the equilibrium constant. Let us begin. In this lesson, we will explain the significance of the value of the equilibrium constant. Recall that the equilibrium constant can be used to determine whether the forward or the backward reaction is more favored. And when the equilibrium constant, or K, is much greater than 1, usually above 10, the reaction shifts to the right. This means forward reaction is more favored, or the product formation is more favored. And when equilibrium constant is much less than 1, usually below 0.1, the reaction shifts to the left. Backward reaction or reactant formation is more favored. When K, or equilibrium constant, is greater than 10 raised to 10, the reaction highly favors the forward direction. On the other hand, when it is less than 10 raised to negative 10, the reaction highly favors the backward reaction. These extreme cases can already be considered irreversible. Consider the following reactions: combustion of methane and formation of diamond from carbon dioxide. The equilibrium constant for first reaction suggests that methane readily combusts at room temperature. On the other hand, the equilibrium constant for the second reaction tells us that it is impossible to produce diamond from carbon dioxide at room temperature. In the previous lesson, we learned that the reaction quotient, or Q, is used to predict the direction in which a reaction will proceed until equilibrium is attained. When the reaction quotient, or Q, is less than the equilibrium constant, or K, the reaction proceeds forward or from left to right to attain equilibrium. This means reactants are consumed until equilibrium is reached. And when quotient is equal to the equilibrium constant, the reaction is at equilibrium. And when quotient is greater than equilibrium constant, the reaction proceeds backward or from right to left to attain equilibrium. In this case, products are consumed until equilibrium is reached. So to summarize, the magnitude of equilibrium constant indicates the direction in which an equilibrium reaction is more favored, and the magnitude of reaction quotient determines whether the reactants or products are consumed to reach equilibrium. These are the references for the lesson, and that would be all. Thank you.